Hello, CRA 101. Welcome to another screencast. This one will cover Chapter 5 from Sherry Diesler's Becoming a Critical Thinker, which will help you understand inductive generalizations. This time we're focusing on controlled studies, expert testimony, and analogies. So just to recap, we've been talking about the generalizations we can make from statistics. And in Chapter 4, we discussed how the conclusions won't be true in every case, and that the conclusion's strength is based on the evidence that's provided. Good evidence equals good inductive strength. And building on the way in which we can draw inductive generalizations, today we're going to take a look at expert testimony and controlled studies. We're going to spend most of this time on controlled studies, but for a moment, let's think of expert testimony. So expert testimony is a two-step flow of information. We get leaders in a field of expertise or opinion. They gather information from their own research, from their own area of expertise, from media, and then they pass the information on to us. And one way of thinking about this is an example of buying a car. Most people gather information before they buy a car. I know I did. And I approached it in a couple of ways. I used the opinion of people who have driven the specific type of car that I was looking to purchase. But then I also went to the internet and I used expert testimonies of places like Consumer Reports or Kelley Blue Book or Car and Driver, Car Gurus. There were many different websites in which I was going to help me make an informed choice on the best car to buy. So using that two-step flow of information, I became an informed consumer, and then I was able to make an informed choice. Some of the problems, excuse me, some of the problems we encounter with expert testimony is that sometimes the experts are in the wrong field of expertise. We want somebody who is an expert at, I don't know, electrical engineering, and yet they've got a general engineering degree. So we have to seriously consider the field in which they are an expert in if we're going to take their testimony as reliable. Some people may not recognize them as experts. Lots of times this happens, say, in a legal case when experts in certain fields are brought in and the prosecution doesn't like the defense experts, or vice versa. The defense doesn't like the prosecution's experts. Some people are paid for testimony. This happens a lot in commercials. If you can think of the testimonials of stars for Gatorade, for Nike, for Proactive, all those people have been paid large sums of money to say that those products work. The experts may be biased. They may bring their own biases to the table because of the value assumptions that they make, or they may be biased because they have stock in the company that they're testifying for. There's lots of ways that experts can be biased, and we need to consider that when thinking of their testimony. Some experts, as equally as they talk about their information, can be contradicted equally and just as easily by another expert. Or finally, they may not understand the limits of their own expertise. Their ego, their hubris, their experience may make them feel that they know more about their field of expertise than they actually know. So some of the things to consider with expert testimony. Okay, moving on to the rest of this screencast is controlled studies. So controlled studies are research designs that use specific methods, and it's when two groups are compared. It can be humans or animals. And it's important because the generalizations that researchers and scientists make from controlled studies carry a lot of weight. They are very strong. And the reason why they're so strong is because a formalized method, specific steps are used that have been accepted worldwide in the fields of science and research as valid steps to take in doing good research. And lastly, controlled studies are strong because they can be duplicated. The protocol that the research design uses is like the recipe for the research study, and anybody can follow that recipe, duplicate it, and get similar results. So controlled studies are inductive generalizations. They are what will probably occur in a given circumstance. And they follow the same idea from Chapter 4, that they have specific elements, the characteristic of interest, the target population, and the sample. If you recall that from polling, that's what you do when you conduct any research study. So the researcher still asks, what do I want to discover? What do I want to know? And whom can I study to begin the controlled study? And the research design has a protocol, subjects, and control. So the protocol is, again, the recipe or the design. The subjects are the people or animals studied to get information about a target population. And the control is the process that researchers undergo of weeding out irrelevant or unrelated factors that could affect the outcome of the study between the two groups of subjects. And the other important thing in a controlled study is that you use two groups, and one group will be exposed to a variable and the other will not be. More on this later. So a good research design follows these 5 steps. First, there's a question. What do I want to study? Then a hypothesis, a speculation about what will be discovered from a research study. Yes, researchers begin with an issue, a conclusion, and reasons in mind when they design research. Then they find their sample, members of the target population who will be studied, and then they create a control group and an experimental group. So the control group is the group of subjects from the sample who get no treatment or a placebo, and they are a test benchmark. And then the experimental group is a group of subjects from the sample who are exposed to the special treatment called the independent variable. So for example, in a medical research design, lots of times there's a control group, which is a group of individuals who believe they're getting medication. They're not told that it's a placebo, a fake. And then an experimental group who actually get the medication, and they're the independent variable. And you compare the results of the two, and that's how we get strong generalizations. So that comparison are the observations made and the information collected by the researcher as they complete the study. And then lastly, the conclusions that the researcher makes, how they interpret the data, allows them to talk about the meanings, the findings, the significance of the study. So some things to think about when you're looking at these kinds of research is a list of questions, and these you have detailed examples of this in your textbook. First is the sample size. Is the sample large enough to produce meaningful results? When we're talking about putting new federally approved drugs on the market, pharmaceutical companies need to do controlled studies that involve thousands and thousands of people, because we're talking about certifying that something is safe for the entire American public. Now, a sample size for a controlled research design at Chandler Gilbert Community College could be less than 100 students and be a reliable study, because Chandler Gilbert Community College is just a few thousand people, and we're not generalizing to the entire population. The moment we decide to generalize to the entire population, we're talking about very big sample sizes. The study, is it reliable? Are the people involved? Is the design reliable? So you need to think about all of the factors that would be included in looking at the reliability of the study in evaluating the research findings. Could there be alternative explanations of how the researcher discovered the findings? So this is another important thing to consider. Can you yourself say, well, that's a finding, but this is also a possibility because they did not control for this in the research design. Another thing that we need to think about is the statistical significance of the findings. This is where we get into numbers. Are the differences between the control group and the experimental group statistically significant enough where if we make the generalization to a larger population, we would find the same number pattern? That's statistical significance. Duplication. Is the research able to be duplicated? Can we do something with this information? Is the recipe sound? Do we get the same results? Does the researcher make too many claims? Is there ego involved and they're trying to further their own professional career based on this one research study? Sometimes researchers get too wrapped up in their own hypotheses and their own conclusions, and they make too many claims. I can think of the example of the researcher who concluded a few years back that vaccines caused autism in children. Once that research was called into question, the criteria for evaluating the research findings were used, these questions were used on it, and they found multiple holes in the researcher's findings. He was making too many claims, he was biased, his results were not statistically significant, but the population had gotten a hold of this information prior to being able to vet or not vet the research, and lots of parents made decisions based on one research design. Problematic, right? Is the institution respectable? Lots of people look at the institution where it comes from in order to decide whether or not the research can also be respected. And then lastly, bias. We also have to consider the biases of the researchers, the biases of the institution, in order to understand whether or not the findings are valid. So as a critical thinker and a critical reader, using these questions, using this criteria will help you do a better job of deciding whether or not the information can be generalized, and we can rely on it to make specific observations and informed decisions. Lastly, the chapter goes over reasoning by analogy, which is simply comparing one idea or plan to another for the purposes of supporting a conclusion. We make the assumption that an idea or a policy process event is similar in one way to another. So the syllogism there is A is to B as C is to D. And we assume that since something holds true in one context, it will also hold true in another similar context. So finally, scientific discoveries are often made through controlled studies. And a well-designed study can be repeated by other researchers and thus can lead us closer to the truth about an issue. This chapter has reviewed good research design, the difference between a control group and an experimental group, how data is used in a good research design, how critical thinking and reading are applied to research, the elements of controversial findings. Although we didn't speak about this directly in this screencast, there's a few pages in the chapter that reviews that. The importance and pitfalls of expert testimony, and lastly, reasoning by analogy. We can use that to both explain and persuade information. So good luck with the activities and the exams that will cover the details in this chapter.